Welcome to week 2. I'm Josh Korick. I'm just putting together a short video for you on YouTube. One to get a little more FaceTime as we go through this online course. I've just built a small fire in my fireplace just to hit up a few of the key concepts of week 2. Our focus right now in week 2 is looking at the history, but then more importantly like the chemistry of our woody materials and herbaceous crops and some of those differences. And right now with the fire that I'm building here, it was just a small little fire. I started with some softwood to get it going, and then I put some hardwood oak on top of that there to keep it burning. But there's 3 main components of a fire that are going to be key as you go through the reading, and that's basically the evolution of water off fire, just like boiling water out of wood. The second is pyrolysis, and the third is gasification. And if you Google pyrolysis and gasification, you can get a better understanding of the 2 different concepts. But they're basically, pyrolysis is the breakdown of a lot of the components that make up the wood. And the 3 main components that make up the wood product is hemicellulose, cellulose, and lignin. When we look at the heat of a fire and things of that nature, the first thing that happens is we have water that boils off. Then we have the breakdown of hemicellulose. Third is the cellulose starts to break down. And fourth is the lignin that starts to break down as well. And so those are the 3. Those overlap with one another. But are significant when it comes to understanding like temperatures off fires. If you're doing any sort of analysis on a facility when it comes to combustion process and pulling like waste heat and things of that sort off, these things can become important. The 4th component is looking at, before you even burn something, how much water is in the fire itself, or in the wood, excuse me. And I brought a bottle of Tide with me out here because when you buy Tide detergents and so forth, most of what you pay for is water. The same goes for wood products and things that you purchase on like the market when it comes to seasoned timber or green timber, maybe crop residues and so forth. You may be getting a residue material or woody material, but you're also buying a lot of water. And so we'll learn a little bit this week and moving forward how much water affects the energy value that you have in your wood products and so forth. Learning the chemistry of wood products and kind of like the compositions and the differences is important, and it's played a role several times in my job. One instance that came up here in the last year was did an analysis for a pellet factory here in Wisconsin that had a wood boiler, and they wanted to collect the waste heat off the boiler for some process to use to heat up some process water. We were unsuccessful in finding a way to do it. And it was because of the type of products they were using to burn was giving us a low combustion temperature, and we couldn't drop it any lower. And so you may think that's the end of the road, but what you can look at, if you understand these concepts a little bit and you understand different properties of different materials, we can actually solve their issue at this pellet factory by looking back at where they're getting their residues, what type of residues they're using, how dry are they, and can we manipulate that at all? And if we can manipulate and change it at all, we can adjust the temperature of the fire, the heat per hour, and we might be able to make a system set up where we can pull off waste heat in that system. So there's one application that where I've used the stuff that you're going to kind of get into and learn this week in my real life and in my job.